Hi, this is Dr. Ronald W. Satz, founder and chair of the International Society of Unified Science. I'm president of TransPower Corporation, a commercial and custom software manufacturing certified systems engineering company. I work as a theoretical physicist and as a systems and mechanical engineer. Today, I'm going to begin a series of screencasts on the two reciprocal system database modules, the Macrocosmos and the Microcosmos. I'm going to start with the Macrocosmos database. We're going to go through each layout, one layout per screencast. So here on the left side, you see the Macrocosmos database. This has the properties and calculations for the universe as a whole. Galaxy clusters and groups. Galaxies, star clusters, stars, planets, moons, minor bodies, nebulae, gas and dust, events, and voids. Comes with a fine graphing program, general progression versus gravitation graphs, and star graphs here. To the right is the Microcosmos database. I'm not going to go into that today, but I just wanted to show this to you because it proves that the reciprocal system is a theory of everything. Of course, I don't have any metaphysics here, but the reciprocal system and its extension to the non-physical realm does cover all of existence. All right, let's begin with the universe as a whole. This is the subject of cosmology. And before we get into that, let me explain a little bit how I set up a FileMaker database. The Help button is right here. If you click on New, you can create a new record. Form is the general display for a record. Table if you want to display a set of records. Find if you want to find a particular record. Sort if you want to sort the records in some sort of order. Print the record or records. Revert the record back to the way it was before you made any changes, and delete the record here. Of course, that's the close button. If you've selected one or just a few records and you want to show them all again, you click that. Now you can see my tabs here. I have the universe, galaxy clusters and groups are there. Galaxies, star clusters, stars, planets, moons, minor bodies, nebulae, gas and dust, events, and voids. So you don't have to go back to the main menu. You can just click here. This is, of course, a relational database, so you can go all the way from the universe all the way down to moons, in fact, with this. It's very interesting. So you can see here, you can click on voids, you can go to voids there, or you can go to these galaxy clusters and groups here. You can scroll down, and you can go directly to, say, the Milky Way. I'm sorry, not the Milky Way, the local group. Somewhere in here, hopefully. Oh, these are voids. Excuse me, I'm in the wrong area. Over here, these are voids. You go here, and I'm going to scroll down to the local group, for example. I'll scroll down, and there's a local group. All right, that's enough on that. Okay, so I'm going to go through each field now. Object name here is the universe. By the way, down below here, it shows you the number of records. I put in a second record just to show that it's okay. The form number, if you duplicate a record by clicking Control D, that'll duplicate the record, but then you should up the form number. So if I go here to the second record, which is blank, the form number is 2. If you wanted to experiment with different values, but you didn't want to change the original record, you would just go here and you can play with the different values. Of course, you can go up or down the database using the other buttons here. Alright, now let's get into some actual properties. Well, right here you show video or pictures, so here I have a list of things you can check on. These are all special files or videos. For example, space-time dimensions, natural unitized physical quantities, and so on. These are my papers here, which you can go to. And also, APOD is the astronomy picture of the day from NASA. It's public shared pictures and so on. And then we'll close that. And events are here. You can see like 25 brightest stars. You would put stuff here which have to do with the universe as a whole rather than with a specific celestial object. I'm not going to click on any of these right now, but you can just see claim superclusters. Superclusters are not true, actually. And most of the galaxy clusters that astronomers have identified are actually composed of groups which are very slowly moving apart. That's about it for that. But see, you can add a picture or video here if you want. All right. Now let's begin. Estimated mean radius in the universe, 50 billion light years. Now, why do I say that? Not only is the universe as a whole cyclical, but stars go through cycles themselves. So a white dwarf does not become a black dwarf. The white dwarf actually comes back to the main sequence. The same thing, a red giant actually contracts back to the main sequence. The first star, first generation, would be an individual star created in a globular cluster. Now, after about 10 billion years, that star will explode as a supernova type 1, creating a binary star system, a red giant white dwarf pair. That's why you see all these red giant white dwarf pairs in the galaxy and in other galaxies. So what happens then? Both of those stars contract back to the main sequence. 10 billion years later, they explode. Again, both of them creating a red giant white dwarf pair. So you've gone from 1 to 2 to 4, and then those 4 can move slowly up the main sequence, and they'll explode in a supernova type 1. So that's another 10 billion years, making 40 billion total. At that point, age becomes a factor, and the age limit of the stars are reached after about another 5 billion years. That's 45 billion years. And then the galaxy itself ejects chunks of matter from supernova type 2 explosions, and these chunks become quasars. These are ejecta from galaxies. Houghton Arp showed this in his Atlas of Peculiar Galaxies. And the quasars can last around 5 billion years before their matter is dispersed into the inverse cosmic half of the universe, which is localized in time rather than in space. If you're not following this, then you'll have to get my Unmysterious Universe and Existence, Interactions, and Computational Treatise of the Reciprocal System, the True Theory of Everything. The two database modules, the astronomical properties and matter properties, are basically the conclusion of the work. So it would be the last thing that you would purchase if and when you want to use the science in your scientific or engineering practice. Okay, so it's 50 billion years, and the maximum speed possible in space is speed of light. So that translates into 50 billion light years. If we had an isolated galaxy group, which is isolated away from everybody else so that it's moving away at the speed of light, that would be the maximum distance, 50 billion light years, that the universe would be. Now, of course, in a lot of cases, the galaxy, or the large galaxy group, which combines into a very, very large spheroidal galaxy, will explode before reaching the speed of light. So anyway, 50 billion light years is what it is. So the diameter would be 100 billion light years. In megaparsecs, this is 1.5337 times 10 to the fourth. And in kilometers, 4.7304 times 10 to the 23rd kilometers. Now from that, we can get the estimated volume of the universe. In light years cubed, it's 5.236 times 10 to the 32nd. In megaparsecs cubed, it's 1.5112 times 10 to the 13th. And in kilometers cubed, it's 4.4339 times 10 to the 71 power. Now, the smooth space density of matter galaxy clusters is stated to be, now this comes from Allen's astrophysical quantities. This has not been estimated from the theory at this point. and that's 0.000012 galaxy clusters per cubic megaparsec. The number of material galaxy clusters, 1.8134 times 10 to the 8th. Smooth density of matter, 2 times 10 to the minus 31 grams per cubic centimeter, 1 times 10 to the minus 7 atoms per cubic centimeter, 3 times 10 to the 9th masses of the sun per cubic megaparsec. It's all calculated based on the estimated mean radius in the universe. Okay, so now we can get the totals for the universe for both the material sector and the cosmic sector. Now note that the cosmic sector is inverse to ours, so there's no symmetry of mass. It's actually inverse relative to unit mass. So this is grams, atoms. Look at that, 4.4339 times 10 to the 79th atom. So they're the same number of atoms, but the atoms in the cosmic sector, of course, have less mass. In terms of the mass of the sun, is 4.5236 times 10 to the 22nd, equaling 1022 times 10 to the 22nd for the cosmic sector. And here you can see the average atomic weight. Smooth space density of M galaxies, 0.02. Estimated number of M galaxies, this is 100 billion. Same for the cosmic sector. Luminous emission in terms of the luminosity of the sun per cubic megaparsec, 3 times 10 to the 8th. Now, the fields that you see in white here are changeable. These represent my best estimates right now. The mean color index of the night sky, that means C equals B minus V minus 0.11, 0.7. Estimated mean lifetime of matter in the material sector and cosmic sector, that's 50 billion years, which is 1.5778 times 10 to the 18th seconds. So it's 50 billion years in the material sector, which is localized in space, that's our sector, and then 50 billion years equivalent in the cosmic or inverse sector, which is localized in time. The estimated cyclical period of the universe is therefore 100 billion years, just double 50. Now, the energy density coming in. The material matter starlight is estimated, it's really, well, it's measured actually, 0.5 electron volts per cubic centimeter. Cosmic matter would be the same, 0.5 electron volts per cubic centimeter. Matter rays, the amount of the energy that's leaving as the quasars discombobulate is 1 electron volt per cubic centimeter, and for the cosmic matter rays by symmetry is also 1 electron volt per cubic centimeter. So here you have the perfect symmetry. Now let's look at the number density of massless chargeless particles. This is the number per cubic centimeter. So we know that for photons it's 823.74. I'm going to skip down here to neutrinos. We know that this is measured here, 110. So by symmetry, the cosmic neutrinos would be 110 as well. The rest of these have been interpolated. The massless neutrons, material and cosmic, should be the same as material and cosmic neutrinos. Now, as for the massless charges, cosmic electrons, material positrons, cosmic positrons, and material. I'm sorry, there should be, 4. Material electrons, cosmic electrons, material positrons, cosmic positrons. These are interpolated. These are more complex than photons, but less complex than neutrinos or massless neutrons. So my interpolation is 467 number divided by cubic centimeter. Now the number density of the cosmic microwave background radiation photons, again, number per cubic centimeter is 411.87. The 21 centimeter radio wave's temperature is 2.636. I say your interstellar hydrogen is heated by CMBR, let me just read it, CMBR photons and matter starlight. And equilibrium is reached at 2.636 Kelvin. And so the thermodynamic temperature of CMBR photons in Kelvin is 2.725. The Hubble constant for the local group is set to 72, that's what we calculated. It's not a constant for the universe. Each galaxy cluster has its own value. Okay, so that pretty much covers it. I guess I could read this. I have notes here. If you own this package, you can, of course, add to my notes or subtract from my notes if you want. And by the way, recently TransPower Corporation has reduced the price of both modules to $95 each. Originally, the Macrocosmos database was priced at $295, and the Macrocosmos database was priced at $195. Now they've both been reduced to the low price of only $95, so it's truly a bargain. Now, let me just read the note here. I think it's important. The physical universe is comprised of two sectors, the material sector and the cosmic sector, C sector. They are imbalanced. The universe is cyclical. There will not be a heat death. It's possible that there are a few other universes in the multiverse with, I better click in here. I can read this. With the central metaphysical realm, the non-physical realm. But each universe is isolated physically, and so the only possible means of knowledge of such other universes would be by intuition, which would come from the non-physical realm. This database module allows entering speculative data for other universes by adding new records, but no means of physical verification would be possible. Recent observations have indicated that the space density of M galaxies may be higher than originally understood, but not verified yet. So this value here might be 300 billion galaxies instead of 100, but 100 billion. But I'm keeping that for the time being. Okay, well that wraps up the first layout of the Reciprocal System Macrocosmos database. For the simplest possible treatment of the theory, please obtain my work, The Unmysterious Universe. Has all the concepts, many diagrams, very little mathematics, very easy to understand. But if you do want all the mathematics, please obtain my magnum opus, Existence and Interactions, a computational treatise of the reciprocal system, the true theory of everything. Then once you get through with that, you can get the two database modules. We just started discussing the Macrocosmos database. The Microcosmos database, as you can see over here, has all the properties of matter, the photons, subatoms, atoms, compounds, alloys, all the properties. It contains a great graphing package as well. All right, well that wraps it up for today. Please study the reciprocal system and prove it for yourself, and thanks for your attention.